So how is a decoder different from a multiplexer? A decoder is different from a multiplexer because it takes an n-bit input and outputs a 2 to the n output, of which only one bit is 1. So the way it works is, let's say I have a decoder. Here's my decoder. And I have an output that has 8 bits. So I've got the bits that are, it's 8 bits of output, and my input, I have 3 bits of input. And let's say my input is 101. What is that the binary number for?
3.
Nope.
5.
5. So that would mean my output would be 000000100. Yep. Only one of these is going to be 1. And it's going to correspond to what the value of this number is. So let's say my input is, I have S2, S1, S0, 0, 1, 2, 3, 4, 5, 6, 7. I'm calling that W. I don't know what the data sheet calls it. Let's say my input is 0, 1, 0. What's my output going to be? Yep. So let's say that we had a 3-variable function. Let's pretend I had a function f of x, y, z equaled the sum of the min terms 0, 3, 4, 5. Then I could use a decoder for this in the following way. I could have x going into S2, y going into S1, z going into S0, 0, 1, 2, 3, 4, 5, 6, 7. And I could take the OR, not the exclusive OR, just the OR of 0, 3, 4, and 5. And that would be my function. And the reason that works is because if my function is the sum of the min terms 0, 3, 4, and 5, then that means that when x, y, z, x bar, y bar, z bar, or x bar, y, z, or x bar, y, z bar, wait, nope, x, y bar, z bar, or x, y bar, z, that is what that function is, because it comes from the truth table where I have 0, 0, 0, 0, 1, 1, 1, 0, 0, and 1, 0, 1. So if any of these numbers show up here, then their output will become 1 over here. And if I OR all those together, that will give me my function. So if you just think about it for a minute, if I had, if my x equaled 0, y equaled 1, and z equaled 0, what binary number is that? That is 2. Is 2 in my minterm list? No. And so if 2 comes in here, do I get a 1 output? No. Okay, but let's say x equals 1, y equals 0, and z equals 0. What binary number is that? 4. And if 4 comes in here, do I get an output of 1? Yeah, so 4 would be 1, and so that works. Okay, so that gives you an idea as to how we would implement use a decoder for a 3-variable function. What are we going to do for a 4-variable function, and what does our chip actually look like? So let's take a look at the truth table for the chip. And there's one thing that's real important to notice about this chip. Look at the inputs. It has E1, E2, E3, A0, A1, A2. So this A0, A1, A2, that's what I was using for my S's. But it has 3 enable inputs. If you want it to work, you have to put ground to E1, E2, and VCC to E3. Otherwise, it's not going to work. Let's take a look at what pins those are. Where is it? It's right here. Okay, so E1 and E2 need to be low. Those are pins 4 and 5. So 4 and 5, as well as 8, have to be ground or it's not going to work. 6 has to be VCC, as well as 16, or it's not going to work. A0, A1, and A2 are our inputs. Now let's take a look. Are these in the correct order? Okay. If you look at how these are written right here, it has 0, 0, 0, that looks correct, and then 1, 0, 0, and then 0, 1, 0. It kind of looks backwards, but that's because it has A0 written first. And so if you just think of it, if you do A2, A1, A0, then it's going to be 0, 0, 0, 0, 0, 1, 0, 1, 0, and in the order that you're expecting. So it's just the columns are backwards. A2 is like S2. A1 is like S1, and A0 is like S0. So it's the 0 is the least significant bit, so that part is important. Now let's take a look. Let's look at like this row right here. This row right there has S2 high, S0, and S1 low. So that would be equivalent to 1, 0, 0. What binary number is that? That is 4. Now let's look at how this is set up. Is 4 the one that is selected? But it's low. No, just because that's the way this chip is designed. Yeah, not because it's minterms. So the way I had it set up before, you have to be careful. We're looking for when it's going to have the low output.
So is it like knotted?
The whole thing is the knot of what I just described a coder to be, a decoder to be. So the way this decoder works is if you have an input of 4, you get output 1, 1, 1, 1, 0, 1, 1, 1. So you're going to have just a single 0 and the rest are going to be 1s. Okay, now let's take a look at how we're going to use this to implement a 4-variable function. So moving on along, because I have to go somewhere. Let's see. The 4-variable function I came up with for no particular reason was min terms 2, 4, 6, 7, 11, 12. 2, 4, 6, 7, 11, 12. 2, 4, 6, 7, 11, 12. So again, make a truth table. So we will have a 1 for 2, 4, 6, 7, 11, and 12. And we'll have zeros everywhere else. Okay, so let's do this the same way. And break this up for the x, y, and z's. And let's write the value, the decimal value for just the x, y, z here would be, whoops, I don't want that one. That's 0, 1, 2, 3, 4, 5, 6, 7. And let's find the ones that have any 1 in them at all. If they have a 1 in them at all, then we'll want to include them. So this one has a, so when we have a 1, what does F equal in terms of W? Not W?
Yeah.
Not W. What about 2?
Also
What about 3? 1. I'll just go ahead and put the 0 up here. What about 4 and 5 and 6 and 7? 0. So now if I take my decoder and I have A2, A1, A0, and I have X, Y, and Z, and I have 0, 1, 2, 3, 4, 5, 6, 7. I want to have when, let's see, I have the low. Let's look at 3 in particular. So when 3 is low, and there's probably a better way to do this. Let's see. I would have when 1 is low and we have not W. By the way, I don't think you have to implement all of these. I think you just have to have them drawn, and then you implement the one that you want. And same with 2. And 5 is W. And 6 is not W. And 7 is 0. Okay, so what I did is I said for all of the ones that have a potential of giving me a value of 1, I'm going to take the not of that, since it's active low, and it with that value right there. And then you can OR all of these together. I didn't leave myself very much room. And then you can OR all of these together. So the only reason I put the not in is because our particular gate is active low. If it was not active low, then what I would do is I would just AND the output with, say, W naught for 1, and W naught for 2, and W for 5 and W naught for 6. And then you would OR all those together. Yes.
So could you just like not the output of the OR gate?
Instead of putting the not in here,
Yeah.
you have to think about that, because you have to think about De Morgan's laws, and so I don't know that would, what would work would be if we had, let's see, if they were all active low. and we ORed those. I'm not sure, I'd have to think about it.
Alright.
Yeah, my brain is too tired to figure it out right now.
Would it be, how would it change?
The zeros, I'm leaving those out because the zeros are not ever going to tell me that my function is true. So I'm just leaving those out altogether. I'm only interested in where I have a 1 or a W in there. Those are the only ones. Just like when I had the 8, just the 3 variable, I only ORed together the values where it was, that made the function true. That's the same thing here. So, can someone look and tell me what your function is, like on your homework? I mean, for your lab?
Like our midterm rules?
Yeah.